Okay. All right. Partly because I don't really feel like covering anything new, um, but also the theme lately has been homework for a change. So, um, any homework questions?
I do, but mine's on some MATLAB code that I'm just getting some errors. So
Okay. Well, that is something we can look into because it's possible that the others might get the same errors. Okay, but seriously, floor's open. Whatever. Okay. Well, I mean, chances are most of the problems with these assignments, with the difficulties, will come from coding
okay.
because it's just that kind of class. Uh, hold on, I brought the wrong pages.
Whenever we talked about what we're gonna do, like 2 weeks ago, and we talked about matrix A,
Okay.
is that the what was A?
Um,
I'm gonna just figure that out.
so,
Did we just call it A arbitrarily, but it was really something
well, okay. So I assume you're talking about problem two. Yeah. So, yeah, whatever system of equations you're setting up to solve that PDE, I refer to that matrix as A.
else? Okay.
Yeah, but when it has the center difference stencil, yeah.
My particular problem is whenever I get to the point I'm trying to work on the right hand side.
Yeah.
And I just basically I get down to that bottom part where I keep getting array indices. It must be positive integers so towards the bottom. Like I can test that one.
Okay, so this part right here.
Yes.
Okay.
And so something in that's obviously not okay.
Oh. Okay. Yeah. So for this right here.
Yeah.
Yeah. That you can't do f of 0
It's not in
because the 0, 1, or 2 is being interpreted as an index,
mm-hmm.
and yeah, indexes MATLAB is 1 based in indexing. So f of 1 would refer to the first element.
Oh, gotcha.
Now, but this part was this part okay?
Well, I mean, it took it as a function handle, and it didn't give me any error. It accepted it as that. But then when I did f of 2, it said the same.
Oh, this isn't a function handle.
That's what it said.
What are you? Well,
Right.
okay. Oh, I see what you're doing. Okay. Okay. You didn't have the app. I didn't realize it was
Oh,
an
I
app.
did that. Oh, yeah.
Okay. Okay, so sign PFX. Okay, yeah, okay, so that's a function handle.
So then, like, you see how I was just trying,
Oh.
but I get this. Well, I was just trying to do it all at one time, and of course, it was like no. So I tried to individually do it to see if I could just have some numbers to test it with, and it's not liking something.
Okay, so just look at F is a function handle. Okay, sign. Oh, here's why. How is phi and phi d defined? Oh, there.
Oh, I did. I just hard coded it.
Okay.
I don't know if that's appropriate, but
Well, okay, so you need that a function handle also? What are
no,
they-
just 5.
and
And I
because
just hard coded that for
Um,
the first review
yeah,
of it.
phi d because
And then I did this as a
Yeah.
hard code, and I
Yeah.
used that in the next function handle.
you'd have to the way you have it F written, you'd have to have phi d also as a function handle because it has an x.
That's what it's in the indices with X are.
Yeah, because here you're indexing into phi. Well, it thinks you're indexing into phi d, but you didn't really mean to.
So what do I need to do to fix
Okay.
it? Make this a handle as well?
Yes.
And make this a handle as
Uh,
well?
Well, that should well.
No, I mean this doesn't have a variable, so it's fine.
Well, but don't index it. So if you make it like a vector, then phi dd parentheses anything won't be allowed.
So what's your suggestion?
Well, when you have phi dd, because it's only a constant, just have phi dd
Okay.
by itself.
Okay.
Yeah. Okay. Okay.
I feel like I shouldn't be asking questions about problem number 1.
You're not. You would not be the only one. Yeah. Okay.
So I have written down because we have to solve. We have to find the solution by using Fourier transform or Fourier approach. So I have like the series written down for what u of xt is. And it's the summation over, from negative infinity to infinity to e to the I omega x times u hat.
Yeah.
Omega t. But then I have written down, I guess the question is, I don't know what my notes mean.
Okay.
Because I have written down that to solve O to the E, and then I have e to the ik times x plus, and then times f hat, and then another term that has a g hat.
Maybe I should just look at it.
Yeah, that would be good. I don't know, was this the solution or to this, or is this the O to E? Because
I'm not sure of that. Yeah, okay, especially a 40 series representation of a solution.
right.
But then, when you're doing this, okay, maybe the best place to work through is here.
Because I went back to what we were doing.
Oh, that's where that energy came from, but
Yeah.
that's not going to help here. Okay, let me go back here. Keep in mind that EVI omega x, minus omega x also needs to be here and here. So really taking the Fourier transform of each term. But that's where, okay. So I'll just review, how do you take the Fourier transform of the various derivatives that you have?
Right.
So, okay.
Because it's the inner product with.
It is. But like, okay, if I use this notation to refer to Fourier transform of something, so Fourier transform of du dt is just going to be u hat dt. So time derivatives will just pass through a Fourier transform. They're not affected. You're just taking a transform of something. You're just taking a time derivative of something else now. And the reason why is if variable minus being to infinity, e minus I omega x, u du dt dx. The ddt part, that can be pulled out because you're integrating with respect to x, not t. Now you have that. And this is u hat. So it ends up being ddt of u hat.
Right.
Whereas this is a ddx, I could not do that. Because, so that applies.
I'm looking at the example that we did from 1.7.
But that applies to UT and UTT. Whereas Fourier transform of UX is going to be IK U hat. If you take higher order derivatives, it's IK raised to that power.
So can we do that for each term?
Yeah.
So wait, okay. So if it's a term that's taking the derivative with respect to t, you do the integral. If it's a
Well, no, I
with
mean,
respect to x,
it's that. I'm just showing you why it was that over
Oh.
here. Yeah. So these are your rules.
but we take the transform of each piece.
Yes. And yeah, so
No, we didn't do that though.
well, the transform is a linear operation, so you can transform each term individually.
Because in the example we did before, we like multiplied by the conjugate and then we integrated.
Well,
So why don't? Because that was what I tried to do.
oh, well, okay. The result of doing that is this.
Oh.
Yeah.
So class we went through that to like show.
Yeah. Yes. Yeah. And for an X case, I don't know if I actually like proved that or anything, but or I think I only did like in a discrete case, not the continuous case.
For number 2.
Yep.
Are we saying that matrix that we built in MATLAB is negative f?
Wait. No. Your system you're solving is AU is equal to F, where A is the matrix for minus second derivative.
Right. The minus d.
Minus ddx squared.
But then it says that, oh wait, it's an approximation.
Yeah.
Well, can you not say?
What? Okay.
Because it says that negative uxx equals f, and uxx is an approximation of that matrix that we talked about.
Yes.
So then, are we saying that negative, if you negate that matrix, then that's an approximation of that?
But not just the matrix, because it's the matrix times the vector u of your solution values. Because A is a matrix represents a approximate differentiation operator.
It's the center difference.
Yes.
Right?
Yeah. So So A times a vector u gives you approximately minus second derivative of u. And that is equal to f. Okay. I'm going to write it out this way. And yes, my not wearing shoes is not a sign that I've mentally lost it. It just means my foot hurts too much. In case anybody else was wondering. All right. So, minus UXX equals f. Discretize becomes minus, okay, uj minus 1 minus 2uj plus uj plus 1 over h squared is equal to fj, because that is approximately uxx at xj. So, and this is j equals 1 to up to n. So the PDE goes over to these n linear equations to solve. But that is equal to a matrix vector product of this, which is what I've been referring to as A, times the vector u1, u2, up to un, and that is equal to f1, f2, fn. Okay. And this is what you're trying to find, the u part. So you would, oh wait, okay. So you form that matrix, form this vector, and then you can use backslash to solve the system. And bam, there's your u. So AU is equal to F. So in MATLAB notation, U is a backslash F.
And f is just this function, but it's
Sorry, what?
f is just this function.
Yeah, it's because your function evaluated at the grid points. Okay. All right. Okay, what else you got? Anything at all? There are no stupid questions. Seriously. Yes, I'm 100% positive.
Okay, in number one.
Okay.
I just wanna make sure I'm understanding this correctly.
Yep.
So you have UTT plus 2DUT.
Mhm.
Why, the D is, DUT is, that's not the same thing as just DUT.
No, so you have a constant sitting here at 2D,
Yes, okay,
and
done.
that you can just
That-
pull out.
But the D is with the two, it's a constant.
Yes.
Okay.
Yeah.
When I see D's with derivative, I
Oh,
think,
okay. Well,
Okay, alright.
considering how many different
So it could be
notations there
like
are for derivatives.
2L or two, okay, never mind, that
Okay.
makes a lot more sense now.
Oh, good. It's good for your own attendance because this video is going to be really boring.
understand how rewriting the problem in number one using the transform, how that helps me solve. Because now it's an OD. Well, it's not. Like why?
Yeah, but PDE is changed into an ODE, but it's a parameter K. So now you can use a method for solving an ODE.
Oh, because they're all either like with respect to T or.
Yeah. Yeah, X is out of the picture.
Okay. Okay.
Yeah, so you just have to dust off your 285 knowledge.
Yeah. Okay. And then after that. I think that's what that was. When we were looking at the waves.
Yeah, so once you have the ODE solved, then you probably, once you have a solution written in a form that is in the hints. Yeah.
Would you just look at this real quick and tell me if anything jumps out at you?
Okay.
Because if that's just
Okay, so then the diagonal entries are negative. Okay, so, and what is H equal to? How many points do you have?
No.
8?
yeah, it's N is 8, so
Okay, so then it's 9. Oh yeah.
no.
All right. So the only thing is, B. Where did you fill in? Show me your B.
No, I think I'll be way up there. It's
Okay. Now that B, because the 2 is positive and the 1s are
so
negative.
I didn't need the
Uh,
negative.
Yeah, you don't need the negative out front because that's the stencil for minus UXX already.
Oh, I did originally have that, but then
Oh.
when you drew it on the board, I ended up putting it back. So
Oh, okay. Well, point is, the two should be positive in the final thing.
oh, so mine's just
So-
the reverse of that.
Yeah.
Okay, because my numbers weren't coming out right.
Okay.
Okay.
Is each grid point X?
Um,
There's N number of those, the same
Uh,
N that we use.
yeah. Each element of X is a grid point.
We just N them.
Yep.
So when I'm testing these, can I just make a function handle for my U hat exact? The exact value that I think it is and put it in and then just compare it initially, not for the plot stuff, or just for me to know if I got the other part right.
So you have a vector. So
So I
you'd be
have
comparing
I
that
have
view.
U values. I calculated that, but
Yeah.
I'm trying to make sure my code's right to make sure that's right.
Yeah, so then you have a vector of your exact solution values, and actually you need that for a problem anyway
Yeah,
to compute the error.
I know, but so that's what I'm attempting to do to compare them.
Yeah, like it'd be a good idea if you plotted both of them and made sure they pretty much matched up.
So you're saying use a plot to compare, not necessarily just look at the calculations to make sure. Because I mean, I use that, and I have values for you, and then I also calculate it. You had.
Well, like plotting can tell you if something like way off, and then if that looks good, then chances are that then you can go ahead and proceed with the error analysis to make sure that the error is order h squared. Should I do a last call?
So I know what, I at least understand the concept of what you're saying to do, but as in like just starting out the plotting stuff, I don't
Okay.
think, I mean, you told us plot against corresponding H values using log to plot error versus H.
Right.
And you told us that, but I know when I get ready to do that point, when I get the rest of this stuff worked out,
Well, okay. First,
do you have any suggestions?
since I don't remember which details I provided, when I say plotting error versus H, so the error for a given H value would be norm of U minus U hat over the norm of U hat.
Yeah, I don't think we did that much.
Okay. Where that's just MATLAB's norm function.
Um,
Yeah. And for plotting, you're always plotting a vector against another vector. So once you get that error, that has to be stored in a vector. And also your h's, they have to be stored in a vector also. Plus, with x? Okay.
It's just, it's saying that it's an unknown variable, which it is.
Okay.
But I'm doing a for loop.
Okay.
I need to do it.
Okay. So
I have to pre-allocate that. And then say, I don't know if I should put that in there.
okay. so really so wherever you have x in your formulas, oh well, no, that should still be I. That's it. There's still more indices. But in your formulas, like for instance in phi, yeah, you have to define x yet.
What do I?
X of I would be I times h. Now you define h. Okay. Now, but it's probably the easiest thing to do before the loop. Since you already have h, you can define x as h times. I think I wrote this down on the board some time ago. Oh yeah. Well, yeah, that also left out your h value, but I think elsewhere. That's actually written down. I thought I just wrote something down using a colon operator. Okay, well, I'll write it down here. So since you define h, then you define x, h times 1 colon n to get all the indices. So it's like an implied loop. And then transpose it to make it a column vector. So then,
That's
that,
pre-allocated.
well,
Or no,
that's your x pre-allocated. Now, in your loop that makes f, wherever you need x, you can refer to x subscript I to pull each individual element of x and use it.
Do I do like literally x underscore I?
No, because vector references in MATLAB require parentheses. Doing something like that. Which same thing over here, right? You'd be storing. I mentioned you'd be storing this in a vector, so you can do that. Like if you have a loop going from 1 to however many h's you're using, then each time through you can compute each error and store it in the ith element of that error vector.
What did you say to do to make it a vector? You just do the.
This will give you a vector. Now 1 colon n is actually a row vector. But I said transpose to make it a column vector because f has to be a column vector.
Oh, so when I plot something and replot something, it's gonna automatically rewrite it. How do I keep them both? Just tell it to hold.
Yeah, if you do hold on, and then it'll keep the
And
next
it's
thing.
just-
Yeah, I bet you could do hold off to disable that.
Will you tell me if I'm on the right track with this?
Yep.
And then the next thing just says if you plot it against log, but first of all, I still need to go back and check and make sure my U and U exact are right. But just I'll do that and then hold on and then compare. But
Okay, so U exact is a red.
mhm,
Okay, so yeah, definitely something wrong with your computed solution.
right.
You said at a minimum it should satisfy the boundary conditions. But then the question is it a mistake in your matrix or on your right-hand side?
Right, that's why a minute ago when I checked the matrix A, the negative, when you had negative there, but I had already made my B such that it was the
Yeah.
opposite of yours, so I'm going to change that.
Yeah.
That was one thing that was wrong.
Yeah. But otherwise, it looked like the matrix was fine. Now, so it could be your anatomy.
But as in, oh, I thought you checked that. I thought you
Oh.
told me that.
Well,
For,
yeah, but I mean, like down to the coding level.
Oh, well, that's for sure.
Okay.
But process of where once I get that squared away,
Okay,
when
so
you say use the log,
oh yeah, for plotting the error versus h, use log instead of plot.
so just instead of this, just do log and then hold on. It'll be essentially.
Yeah, I mean, for plotting solutions, you use plot. But for plotting error, it's log.
Oh, okay.
Because that's the only way you'll see those lines that I talked about.
Okay.
Okay. Those double quotes in the plot statements.
For red.
Oh, okay. Because for so long, MATLAB's always been single quote, but apparently it allows both. I didn't know that. Okay. So. Yeah, so
I just have to go back and figure out one of them has an error.
Yeah, it's probably F, just because the matrix is pretty easy to check, and if the sign being off would not cause a difference like that, it would just negate the solution. As far as the F is concerned, I don't think if, I'm trying to think where a mistake might come from, like maybe way things are parenthesized or something. I don't know. I'm grasping.
Oh, yeah, that's the one I did as a handle,
Yeah.
and then. Yeah, I think my A is okay, it's not that.
Yeah, probably not.
So if my N is 8, then the interior grid points would be 8,
Well,
or this.
so there'd be 1 through 8 times H. So H would be 1/9. So your grid points would be 1/9, 2/9, 3/9, up to 8/9.
Oh yeah, that's what I have.
Okay.
So that part's right.
Yeah.
So then. So I get this for my f of x's notation,
Okay.
and I just tried to save it. Like I just tried to restore it as just like f on right hand side, but it gave me. So what's this just mean? All of those
Yeah.
multiplied by that?
Yep.
So is it okay to do like f right hand side equals f of x and just store it like that?
Well,
Or can you not do
don't give
that?
the same name.
So I need to name it something different.
Yeah, because.
So maybe that's why it's.
Oh
not.
well, well, our one's probably would have given you some error, at some point.
the same thing.
Well, let's see how it's implemented.
So we said that, I just checked those X values are right, and then I did f of x here.
Okay, so,
And then I took those values and stored them as just an upper
Okay.
right hand side,
yeah,
and then did.
Yep.
So those are the same. And that's the same thing that I had
Okay.
before. So then when I had a
oh, right. Okay, okay, F. Okay,
no, it was a handle, it was
Yeah.
that.
okay. So sine phi of x times phi prime squared minus cosine phi double prime. Okay. 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 Um, all right. And then is 9 pi x squared. Okay. D is 18 pi x. All right. Then phi dt is just 18 pi. Oh wait. Okay. Yeah, 18 pi. All right. And then exact. Oh, that's a function handle also. Or, okay, yeah. Yeesh. Okay.
Okay.
Oh. Okay. Sorry. Okay, so exact. Oh, oh wait. Okay. Right. Okay. So A is actually I'm gonna do it short full A. Okay. Yeah, 1, 2 is on diagonal, minus 81 above, minus 81 below. Okay. And h squared, 1 over h squared is 81. So, dang it. Not a little embarrassed. So I should be able to spot what's wrong.
I sure can't. I don't know. I keep looking and I just don't know.
Yeah. Okay. But certainly the matrix is right. Okay. But yeah, the solution's not even satisfying the boundary conditions.
So I can just do full A anytime I want to check and make sure my matrix is right.
Yeah, just convert converts it to get reform. Okay, so yeah, like that. Yeah, that looks more like a sine wave. But what the exact solution should look like. But then, actually, from your right-hand side itself. Oh,
Yeah.
oh, right. Okay, that's pretty large, which already seems kind of odd that it'd be that big. But but again, phi prime squared. Yeah, okay, so phi prime is 18 pi x. Okay, and 18 pi squared is going to be pretty big. So, let's see now. Phi of x. All right. So that's. Well, actually, let's try the sine of phi of x. Whoops.
Oh, yeah.
Okay. Well, okay, that's also the exact solution. All right, but at least it's behaving reasonably. That starts out positive and goes negative and starts heading back towards 0. Okay. Now, pi x. Okay. But yeah, f as a whole is not supposed to satisfy boundary conditions necessarily, but although. Okay. Okay, so from 0 to 1. Okay. Yep. Yeah, you think that would at least be something that satisfies boundary conditions. One thing I'm wondering about is what if you used more grid points? Like you're using 8.
Yeah, I just did so I could try to have like
Yeah.
some checkpoints to be able to.
Like here's what happens if you use a larger number, like maybe 100. Oh, I still think the solution would be more accurate than this, but it might shed some light on what's going on, like what part
Just
of
pick
what.
a larger end.
Yeah.
And try it again.
And then go for the same things. And, do you have all those commands like in a script, or are you just typing them into prompt?
No, I just have to.
Okay, you might want to put them in like actually you can copy them from your Oh, okay, this window's not showing, but you go to layout, command history. Yeah, you can copy and paste from here, whichever ones you need, like into a file, and then you can keep running that.
Just pull the ones that I used.
Right, yeah.
I just
Yeah, to define A and F. Because also, since there's so many things happening in a prompt, I wonder if something got overwritten or something that that could have messed things up.
We're supposed to tailor expand that center difference.
Yeah.
Isn't that already a tailor expansion?
Well, okay, that formula came from a Taylor expansion, but what you're doing here is since you have u of like x, u of x plus h and u of x minus h, you Taylor expand those because that will introduce.
Separately?
Yes, and once you substitute those in there and simplify, then you'll get like that'll introduce uxx into the picture, which you can say is minus f. And then whatever it doesn't cancel will be your error.
What I found here was the approximation of UXX.
Well, what it's starting with is the approximation. So once you put in those Taylor expansions and simplify, you'll get uxx plus other stuff because it's an approximation.
Then what's all this MATLAB stuff I just did?
Oh, well,
I feel you.
this is a MATLAB and on paper problem.
So you do MATLAB to get the approximation, and
Yeah.
paper gives you the true solution.
Well, okay, what you work on paper shows you what the order of accuracy is supposed to be. And then presumably that should be consistent with your plots of the error.
Plots, oh my god, with plotting, that's what she's doing.
Yes, I talked about that a while ago. Okay.
Yeah, it's in here somewhere.
Okay, good. Yeah, this room is legendary for that. And nothing ever gets done about it. You'd think they'd be in winter mode by now, like cranking up a heat or something. Well, there are only 9 minutes left in the class period anyway, so this is your last chance. And there's always Wednesday.
Is H the point I'm Taylor expanding around?
No, X.
X.
Yeah. Yeah, like, that's the center of your expansion. So I just went ahead and implemented that myself with 8 points, just like you did, and mine looked exactly the same as yours. And then I went ahead and just made the only change being more points, and the and it works. Like the exact solution really does agree.
So I just did 128 because you just said powers of 2. So does that
Yeah.
matter?
Not really, but but here's why. Um, yeah. I'll show all of you. This is what the solution looks like. The exact solution, very oscillatory. You were trying to represent that using 8 points. Yeah, it won't capture a behavior. So yeah, your code was right all along. You're looking for a bug, and you never would have found it ever. And it's driving me nuts, but I couldn't find one because there wasn't one. And it's like, okay, let's try this out for real. Okay. Okay. Carly, is that something I can help with?
I feel like I'm having my hand held for every single step of this problem.
Well, it was the first MATLAB problem of the class, so doing something entirely new. So that's bound to happen, and then there will be less of that as assignments go on. Something to feel bad about.
Just I haven't done a Taylor expansion in a very long time.
Well, that's another factor. Yes, it's not since Cal 3 probably.
I feel like things should be canceling out before I even like my X has a factor of pi in it, so the sign
Oh,
should be 0.
whoa! What are you expanding? Hold on.
I plugged it into
Oh no. Okay, no. Okay, you're not dealing with a
Oh,
specific problem. Yeah. So your Taylor expansion will have just u of x or ux of x or
I
ux.
did f of x because I had to do
Oh,
the
well,
equation.
Well, f will appear. F does appear, but it's only you just leave it as f.
F appears.
Well, not immediately. No, what I said earlier. Because once you get uxx, you use the fact that uxx equals minus f.
Did I get? Can you come make sure that I got UXX?
Okay.
I mean, this makes A. This makes F. That finds U. So I got this is U.
Well, that might be the same. That kind of reminds me of Jessica's U, where it starts as a constellation, but there's not enough points to really
Okay,
see
so
an accurate solution.
if we go here and change this to 20.
Oh.
No, that's not what I need to talk about.
Okay. Well, okay, that's a little more reasonable now. But But yours is gonna be looking at the cell expansion.
Yeah, I don't know if I'm doing it right, but I don't want to do all this.
So this is expansion x plus h.
Okay, wait, yes, yes.
Alright, so I think it's, what you have in here would be x plus h minus x. So the point you're evaluating at minus the center, yeah, x plus h minus x, but that just condenses h. Because you're, okay, what you're expanding is so u of x plus h. Alright, so then you're first going to be u of x. Now, well, okay, the general form would be j derivative at the center over j factorial times the evaluation point minus the center raised to whatever power. But that's just going to become h in this case.
Every time?
Well, if you're expanding something like that, yeah. But the point is, it's the difference between the evaluation point and the center.
But it's still gonna be to whatever power.
Yes. Yeah, so you had everything right except for that one little thing. And actually, I think even when you guys did have Taylor series in Cal Free, you didn't even use them like this. So.
It's weird to see it like that, but I still don't know what U is. I mean, like, how am I plugging in U, or am I just saying like RU?
You leave it as U.
Okay.
Yeah.
Or, okay.
Because really what you're doing is you're expanding, like, okay, your local truncation error, since Sarah's going to make sure it shows up on video, your local truncation error is AU minus F. Now, AU is your center difference that you're working on now. So you got that part. Don't forget to subtract off the F. So when UXX appears in here, there's going to be a minus F, but this is minus UXX, so it flips to be a plus F, which cancels with this F.
Okay.
And that's why whatever you have left is going to be, it's supposed to be order h squared. So, so once you cancel anything that you can, then the dominant term left over should be order h squared. And if not, you made a sign mistake somewhere.
It's just getting bigger.
What?
It's just getting bigger. There's nothing you can't
Bigger? Well, okay. How far are you going? Oh, okay. Well, then, let's see. Maybe one term more, but and yes. So that's the case that u of x plus h. Then you do it again with u of x minus h.
Then stuff should happen.
Yes, but not before that. Yeah, because there you'll have powers of minus h, which will cause certain terms to cancel.
But the h squared is gonna stay constant.
Yes, it will.
Wait, all the even stuff's gonna stay constant.
That's fine now. But don't forget, you also are subtracting off minus 2u of x. That's part of the approximation. and you want U double prime to stay because that's what gets replaced with minus F.
Get replaced with it.
Yeah, because U is the exact solution, therefore UXX is equal to minus F. And don't forget, because really what you're have is a minus 1 over h squared u of x plus h, because that's your expansion. That, which you just leave as is, and then u of x minus h, your other expansion. All of that minus f. So just don't forget these other things, like dividing by.
But I'm subtracting that and I'm replacing that?
Yes. And then simplify what you can.
Let's go with it.
Well, what's left?
I can't. They have variables.
That's not necessarily a bad thing. Okay, what cancels?
Well, this cancels.
Well, this minus 2 just plain u of x, not u double prime.
But it's that.
Well, that's another thing that's subtracted off. But yeah, all of that, with that included, gets multiplied by minus 1 over h squared. Then subtract the f. So what else cancels?
Did I not already do h squared?
We still need to divide by h squared. Yeah, so what you have done so far
Cancels.
is just the part within the square brackets.
So then if I divide this stuff by h squared.
Well, have you canceled everything that you can though?
Yeah, it's just 2. And that would cancel.
Yeah, okay.
2 of these would cancel.
All right.
The u's are still there, just the u's
Um,
solid.
Well, yeah, but how many do you have?
Oh, those are 2.
Yeah. Yeah. Okay.
Doesn't really matter what my denominator is.
Well,
Wait, it's
well, yeah, well, you get 2 of them.
12.
Okay.
Do basic math.
All right. So now, you took the one over h squared into account. Don't forget the minus. Well, the minus is far left. And then now you replace and subtract off f. U double prime is equal to minus f, so that would be a plus. Yes. And see what happens. Order h squared error.
So,
I can stop the video before a file gets too big.